Welcome back. We're about to start a new session, and looking back at what you know, you've actually accumulated some pretty strong superpowers for web coding. You've learned the basics of the 3 essential technologies that go into creating web content, that is HTML, CSS, and JavaScript. And you saw how these could be integrated in the browser to create a nice web experience. You've got all the basics down, and you know the lay of the land and are perfectly capable of going out and searching for what you need now in order to write some good basic web content. So now moving forward, we're going to start exploring some more in-depth topics. In this session, we'll start by covering color, and then we'll talk about the important computational thinking concept that we've identified as events. And then finally, I'll show you how to use the browser in order to debug your code. As code gets more complex and your programs get longer, you'll want to be able to see errors, print out information about your programs, and the like to the console window and use those developer tools that are built into the browser. So that's what's ahead for us in this session. But first, we're going to start with color. So recall from your childhood that we combine colors together to create new colors. One way we can represent any color is as a combination of red, green, and blue. In code, we have several ways of doing that, several ways of expressing the combination of colors in different syntactical forms. As you can see on this slide, I use first RGB. RGB stands for, obviously, red, green, blue. This is a function type of syntax, and this function takes 3 arguments. The first represents red, the second green, and the third blue. So in this representation, we're using percentage units. And the numbers then would be between 0 and 100. We also have another way of expressing RGB in this functional notation. And we use numbers between 0 and 255, where 0 is no trace of a particular color, and 255 is the full amount of that particular color. And we'll look later and see why the number 255 happens to be used as the maximum. Another way that we'll be looking at expressing color is in hexadecimal numbers. And I'll call those hex numbers for short. So we represent a hex number using this hash symbol, and it's followed by 6 digits. The first 2 represent red, the second 2 represent green, and the third 2 represent blue. But in all cases, we're just combining red, green, and blue to create any of the colors that we need. So next, I'd like to talk about units and number ranges for specifying colors. So here, I'll talk about different bases to represent numbers. You may have seen this in a math class from your childhood, but we'll just do enough of a review here so that you can understand the color specs when you see them in code. So with decimal numbers, we have digits between 0 and 9, 10 digits altogether. When we're counting and we run out of digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then we use an extra digit to represent the different units. So then when we say 10, we have a 1 in the tens place and a 0 in the ones place. Similarly with 3 digits, 1, 0, 0 represents 100, which means there's a 1 in the hundreds place, 0 in the tens place, 0 in the ones place. So in computer cultures, we often use hex. Now hex has a base not of 10, but of 16. Therefore, we have to have 16 individual digits. And those digits you can see here listed, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Where F is the hexadecimal equivalent of 15. When we need the next higher number, the equivalent of 16, we move to 2 digits. So then we have a 1 in the 16's place and a 0 in the 1's place. So you can see here, as I've counted up, 9, A, B, C, D, E, F, 1, 0, 1, 1, 1, 2, dot, 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 and then we start using the letters. What comes after BF? F is already the highest digit in hex, so we bump F up to 0 and B up to C. Therefore, after BF comes C0, C1, etc., until we get to FF. What comes after FF? 1, 0, 0. 0 in the 1's place, 0 in the 16's place, and a 1 in the 256 place. We have 1, 256. So 16 possible digits, and the nth digit has a weight that's 16 to some power. 16 to the 1 is 16, 16 to the 2 is that third digit, which is 256s. Now, in HTML and in CSS, color values, as I said before, have a range of 0 to 255 in decimal. That corresponds to a range of 0 to FF in hex. And it's kind of interesting to understand, just as an aside really, why 255 is the maximum decimal number that we use. Well, one sort of reason is that 255 gradations of a color is in a sense enough. The difference between 255 and 254 is either not noticeable or minimally noticeable. But there's another reason for this, and that has to do with the way hex numbers are represented on a computer, or the way any number is represented in a computer. So on a computer, we represent numbers in binary form. Well, binary is just another base, and it's base 2. On the last slide, we saw base 10 and base 16. Well, binary numbers are base 2. We count 0, 1, then we need an extra digit already, 1, 0, 1, 1. Then we need another digit, 1, 0, 0. So binary numbers only have 2 digits, zeros and ones. So it turns out that a byte in a computer is 8 binary digits. And each unit of 4 is the equivalent of 15. So we have, if you have the binary number 1111111, then that's a byte, and it's the largest number you can represent in a binary number with 8 digits, and that happens to be equal to FF in hex and 255 in decimal. So that's the historic reason why 255 is the largest number that we use for color values in decimal notation on computers. So now that we understand these different bases, I'm going to share a little joke with you, a little geek humor that involves your understanding of binary numbers. Moving right along. So another way that we can represent color in our computer languages, instead of red, green, and blue values, is with hue, saturation, and lightness. So these numbers will represent something different, but it's important to understand that they cover the same range of the entire color spectrum. So with hue, saturation, and lightness expressed in this functional notation with 3 arguments, the first argument is hue, the second saturation, and the third one lightness. Hue is expressed as an angle between 0 and 360 degrees. And that corresponds to the direction of this arrow on a circle. Saturation and lightness, on the other hand, are typically expressed in terms of percentages and have numbers between 0 and 100. So you will sometimes see hue, saturation, and lightness expressed in terms of proportional notation. In that notation, hue, saturation, and lightness all take on values between 0 and 1. The context when you program will be clear and you'll know which one you have to use. But in both cases, they're expressing the same thing: hue, saturation, and lightness. So let's try to get a better understanding of what hue, saturation, and lightness are about. To do that, we'll do a little search on the web. So here we have a color picker application, and there are lots of them on the web. Have a look, search for color pickers. Some are better than others, but this is perfectly adequate for illustration. With a color picker, I can move a point around with my mouse on a space and change the color, which is represented in the upper right-hand side, that I'm choosing. Now, as I move, we can see the different representations for the color along the right-hand side. We have hue, saturation, and in this case, brightness instead of lightness. Or we have RGB, red, green, and blue. Each one of those triplets represents the same color. Along this bar, I have the hue. You can see that in the hue, saturation, and brightness representation, as I move the point along this bar, only the hue is changing. So this is what hue is. You can get a sense, an intuitive feel for that by exploring that. If I wanted to change only the saturation, I could just change this number 72 to 100, the maximum value for saturation, and I get a fully saturated blue. If I wanted to get a slightly saturated blue, I can set this to, say, 20, and I get a less saturated blue. So you can explore these numbers and understand how these number systems work. Hue, saturation, and lightness is often very convenient to use as a color, because often what an artist might want to do is fix the saturation and lightness and only change the hue. And again, we see that that is really changing what somebody like me, who doesn't work with color every day, changing the color. The saturation and lightness mean other things. Brightness, of course, is the darkness or lightness of the color. If I darken it up, say to 10, I can see that it approaches something like black. But this is just a way to let you know that you have a couple of different ways of representing color, RGB and HSL, and both are used frequently in both CSS and JavaScript. So by way of review, let's look at all the different ways that we can express a value for a particular color. We can use the word for that color, in this case blue, in the form of a string, and we saw how we could do that in both CSS and in JavaScript. We can use the RGB functional form with decimal numbers between 0 and 255. We can use the RGB functional form using percentage units with numbers between 0 and 100. We can use hex numbers, and we think of these as pairs of values with 00 representing red, 00 the second two digits representing green, and the last digits representing blue. There's also a shorthand representation in hex. We use the hash followed by 3 digits, and each digit represents either red, green, or blue. And finally, there's the HSL representation. And for that, I show here the first argument as a number between 0 and 360, representing an angle, the second number representing saturation in percentage, and the last argument representing lightness as a percentage. Now, in fact, if you look closely, you'll notice that not all of these colors are blue. Can you see which one is not like the others? As I hope you noticed, it's the second one. RGB has 255 as the first argument in this line of code. The first argument represents red. So in fact, this line of code represents a full-on red color. Finally, there are other forms of some of these functions that take a fourth argument. That argument designers refer to as alpha. And alpha refers to the level of transparency. That is, whether or not you can actually see through the color to what's behind that object on the screen. Alpha takes on numbers between 0 and 1. where 0 is completely invisible and 1 is completely opaque. And by opaque, we mean it's not transparent at all. So those functions include the RGB A function. And then the fourth argument is the alpha. And that's true for both the units that use 0 to 255 and the percentage units. But still, even in the percentage unit version of this function, the last argument, alpha, takes on values between 0 and 1. There's no way currently to express colors with alpha in hex. The way we manage this in CSS is we express the color in hex, and then we set a separate property called opacity. HSL also has a version, HSLA, which has 4 arguments where, again, the last argument is alpha in the range of 0 to 1. I also need to point out to you that there's a little bit of a difference between how we express CSS properties and JavaScript properties on the styling object. We saw in CSS that we were using a background-color property, and there were also many other properties, and they're generally properties that are spelled with all lowercase letters and with dashes between the individual words. However, in JavaScript, we use something called camel case. And the reason it's called camel case is because each word in a property name is not separated by dashes, and instead, all words except the first have capital letters. And therefore, it has somewhat the look of a camel. So it's called camel case. So all JavaScript properties for styling are in this camel case notation, but otherwise are similar to their CSS cousins. Background color is background color in camel case, etc., etc. And the other thing to note is that in JavaScript, we always have to provide our styling property names in quotations, thus as a string. So that's the difference, and when you look on the web and you're doing your search, mash, and modify style of coding, you'll see properties sometimes in CSS or sometimes in JavaScript, and there's this slight difference. The names are the same, but I've shown you now how to recognize or how to transform one into the other, depending on which system you're using to specify your styling properties. So this is what it looks like actually in CSS. If we're setting the value of a color display ID object, then we'd say background color blue. Blue is not quoted, as you see here. In JavaScript, what we've done and what we will continue to do is first get an element by ID, assign it to a variable, and then set the respective property that we need to do by identifying the object, the style object, the property we want to set, and then the value we want to set it to as a string. So in JavaScript, we often want to create these RGB functional notations for color specification. But as we just saw, we have to provide them as strings. So we have a little bit of programming to do. Luckily, you already know how to do that kind of programming, but it helps just to review that and see how we do that. So how could we create an RGB string for doing some styling with color if what we actually have are numbers and not strings that represent those colors? And this is how we do it. We use the concatenation operator with strings and numbers. And as we saw, this concatenation operator converts numbers into strings first and then concatenates them into a coherent string by placing them end to end. So if we wanted to create a color string that looks like RGB 100%, 100%, 0%, this is how we would do it. We would string together the elements that are already string values and concatenate them with the number values that we want to see. And later we can change these numbers easily enough, or we could include this line of code, this color string line of code that I have right here, in a function, say. That function could take arguments that specifies the color, and this little line of code would translate the arguments for color into the string we need to set the color. And that's what we'll do coming up in future lessons.